Hello friends, now I'm going to discuss the next example, and that is nothing but also biased diode clipping circuit. We are discussing here a positive bias diode, or you can say diode clipping circuit. Now let me draw that input signal first. Over here this vertical line represents the amplitude and this horizontal line represents the time axis. So we draw this one first. This is V input signal. We are considering a sinusoidal input signal. So this one is a positive half and this is a negative half. I'm repeating the cycle. Positive half and this is a negative half. This one is a time and this side is an amplitude. This one is a plus Vp and this is a minus Vp. Overall, you can consider this one is a V peak to peak signal. We can take any of the values and this one is considered 0. Starting from 0, this sinusoidal signal, we are considering over here 2 half cycles. Now I'm going to draw that circuit. This is also we are considering positive bias diode clippers. I'm drawing that circuit. This one is a shunt diode clippers because diode is connected in shunt part. Parallel clipper circuit, also you can say parallel clipper circuit, but these are biased one. We are providing biasing supply. Over here we'll connect the input signal, input supply. This is nothing but V input, positive, negative. This side we are going to check the output terminals. Now let me connect the diode over here. I'm going to connect diode over here, and these are bias, V bias, and over here resistance. So I'm drawing that resistance. You can give R, R1, something, whatever you like. This side I'm connecting the diode, but the direction of the diode is different this time. And over here I'm connecting V bias. So this is V bias. This is diode. We are considering ideal diode. And now we want to check that what will be output waveform. So now let me draw that one over here. Below this V input I am drawing V output so that you can understand how that positive half cycle and negative half cycle in both the time how the diode is reacting to the open circuited or short circuited, forward bias, reverse bias, everything. So over here I am writing V output, and let me take all the points so that it will be easy to understand. This positive half cycle, this negative half cycle, this one positive half cycle, and this one is a negative half cycle. Over here I have written positive bias. So positive bias means this is plus, this is minus. Same way, this is plus, this is minus. So upper terminals of bias voltage is similar side, and lower terminal is both the polarity similar. That is why this one is a positive bias. So positive bias means over here I can take over this side V bias, V bias, V bias. This is plus Vp, and over here minus Vp. Now this V bias is some positive value, but it is lesser than plus Vp. That I am considered in this example. Now let me check what will happen to the positive half cycle and negative half cycle. So what will happen? See, for the positive half cycle, it's starting from 0. At the time of 0, what will happen? Suppose it is 0 over here at the V positive or anode side. and this side is V negative, so minus Vn, that should be greater than 0. Then only this diode in forward bias. So that condition is for ideal diode only. We consider this diode is ideal diode because nothing given, it is not silicon or it is not germanium. If it is silicon, then we can consider this one. This should be 0.7, greater than or equal to 0.7, right? If it is silicon. If it is germanium, that should be 0.3 for the forward bias of the diode. Now here what will happen, you see, when it is 0, already some positive supply available here. At this point, some positive supply already available, but over here it is already 0. So at the cathode terminal it is lesser value, at the anode terminal it is higher value. So what will happen? Initially this diode, this D is forward bias. Simply we can say that when the diode is in forward bias, this bias supply directly we can get at the output terminal. So you can say V output equal to V bias at this condition. Whenever this diode is in forward bias, we directly get V output equal to V bias. Now you see we have to draw that at the output side. So you see this point, at whenever this V input is 0, at that time we are directly getting this V output V bias. So that will act over here. Suppose you are taking this way, here is V bias. If I draw that one, if I draw this one, if I draw this a thinner line, this is nothing but V bias value. At that time I can plot this one at this point and this point. Up to this point this will be straight. Okay, up to this point this will be straight. And what will happen, you see, up to this point this will be straight value at the output because that diode is in forward bias. Now at one point what will happen, this V input equal to V bias. So at that time when V input is equal to or greater than V bias, what will happen, you see, at that time diode is in reverse bias. So that is this point, you see this point, this is that point, this one. At this point V input is trying to get above V bias, and at that time what will happen, diode is going to get reverse bias. If the diode is in reverse bias, if you see diode is in reverse bias, this one will be removed. So what will happen, whatever supply V input is there, it is directly reached at the output side. So we can directly say that V input equal to V output at this time when diode is in reverse bias. So at this point diode is in reverse bias, so we are getting V input equal to V output up to this point. Now once again what will happen, this V input is trying to get down from the V bias supply. So at that time once again this condition reaches this one, and once again diode is in forward bias, and what will happen, we are going to get diode is in forward bias, V output is nothing but V bias. So at that point you can directly say up to this one, up to this next reaching point, see this one, let me draw it properly, at this next reaching point, up to this point we are going to get flat output. This is nothing but a flat output, and this is the second point where we can put this one, like in first half we have follow the same situation. over here it will follow the same situation. Once again, this V input is trying to get above V bias. At that time, once again, this diode will going to get reverse bias, and at that point we can draw V input output, V input equal to V output. So that is what we are going to get over here. This V input equal to V output. Once again, at this point it will be straight. So likewise you can say, let me draw it properly. Here is up to V peak. So this will be like this. So this is nothing but exact output waveform. And once again it will be a straight line from here. It will be straight line up to a next half like this way. This is going to follow like this way. So this is whole circuit, whole output value you can say. Now suppose you are getting some value, like in one example we have considered some value. So you consider this V input is nothing but, you say, a 20 volt peak to peak it is provided. That means this is 10 and this is minus 10, and this V bias you consider that is nothing but 4 volt is given. So over here it is a 4 volt, we consider 4 volt, this one is a 4 volt. So at 4 volt it is a sharp value over here, and once again it is reached. So likewise you should consider that how this positive bias is acting and how this diode is getting forward bias when V input is V input minus, like V positive minus V negative of the diode, means anode and cathode subtraction is greater than 0. At that time diode is in forward bias. So whenever this diode is in forward bias, it will be shorted, at that time. This V bias is directly appear at the output side. It is directly appear at the output side. So V output is nothing but V bias. So in that case, if we consider this example, we'll get 4 volt at the output side, and that is nothing but it is shown over here, 4 volt at the output side. But whenever this V input is going to appear greater than V bias at this point, at this junction, at this point, this V input is trying to go above 4 volt. At that time this is above 4 volt. You see over here it is trying to get above 4 volt. V input is trying to get above 4 volt. This is already 4 volt. So this diode will going to get in reverse bias. That is reverse bias. That means this input is directly available over here. So that is nothing but V input equal to V output. So this is what V input equal to V output up to this point. Once again at this point this V input is trying to get below 4 volt, and that time once again we are getting V output equal to V bias, because diode is in forward bias once again. So this is whole idea behind the positive bias diode clipping circuit. I hope you understand properly, and if you are not understanding, watch the video once again slowly, write it, draw it, try to understand each and every point. Thank you very much.